Hey Matrix, welcome back to the next video in the physics playlist where we're going over the past paper of the November 2020 paper. This video will be covering question 5. If you don't have the paper, please pause the video now. There's a link in the description where you can download the paper as well as the memo. Once you have the paper and the memo, then we can continue with the question. Okay. Let's get started with question 5. So question 5 is looking at a roller coaster, an object, or we've got the cart moving along the path. They've given us that the cart is 200 kilograms. The engine is switched off when traveling between A and B. And then at point A we have 10 meters, we have 4 meters per second. Point B we have a height of h, 2 meters per second, and at C we have a height of 22 meters. Okay, they've also indicated here that during the motion from point A to point B, 3.4 times 10 to the negative 3 joules of energy is used to overcome friction. Okay, so we know we're dealing with non-conservative forces because now friction's involved. Okay. So 5.1 is just your definition, so you can go and check the exact definition from your definition list for non-conservative force. Okay, so 5.2 is where the calculations start. So 5.2 says calculate the change in kinetic energy of the car after it has traveled from A to B. Okay, so even though there's a change in height between A and B, remember kinetic energy is independent of the height of the object. Okay, it's just looking at its velocity. So, looking over here, we have that at A, we have 200 kilograms, we're moving at 4 meters per second, and we have a height of 10 meters. Okay. At B, we have 200 kilograms again, we have a velocity of 2 meters per second, and the height is h. Okay, but we don't need height for this one because we're just dealing with kinetic energy. Okay, so we're dealing with the change in kinetic energy, which is then going to be a half times my mass V final squared minus V initial squared. Okay, and the mass stays constant, so therefore we shall have a half of 200. V final was 2 meters per second negative 1, and that's all going to be squared minus my initial velocity, which is then 4 meters per second. That's going to be squared, and if we plug that into our calculator, we should get a total of negative 1200 joules. Okay, just interpreting this, it's negative, energy is negative, therefore energy has been lost in this system. Okay, looking at 5.3, 5.3 says use the energy principle to calculate the height of h. Okay, now remember we have a non-conservative force that's acting here, which is friction. So the energy principle says we can use the work of the non-conservative force, which will equal to the change in my kinetic energy plus the change in my potential energy. Okay, just remember that energy is equivalent to work. Okay, so getting started over here, I'm first going to manipulate everything and then I'll plug in my values to find my final answer. Okay, so we're going to have the work of the non-conservative force is going to be equal to change in my kinetic energy plus change in my potential energy. Okay, now please note that we did calculate the change in the kinetic energy at the top here, so you don't have to re-show this calculation, you can just substitute your value in. Okay, so I'm first going to take kinetic energy across, so that's going to become work of the non-conservative minus delta K equals delta, or change in my potential energy. Okay, I'm isolating my potential energy. Why? Because the height which we need to find sits in my potential energy. Okay, now I'm going to write out my potential energy. So work of the non-conservative minus delta K is going to equal to mass times gravity times the change in height. So h final minus h initial. Okay, now to get h final on its own, since that's what we're looking for because we're moving from A to B, okay, I want to get H final on its own. Yes, I'm going to divide both sides by mg, and then I'm going to take this across. Okay, so I'm going to end up with work of the non-conservative force, non-conservative, minus delta K all over mg is going to equal to H final minus H initial. Now I can take the initial height across and I'll have H final on its own. So finally we will have work of the non-conservative minus the change in kinetic energy all over mg minus my initial height will equal my final height. Okay, now substituting everything in. Okay, please note that the work of the non-conservative force here is your frictional force, which was given up here. Okay, but remember, friction's taking energy out of the system, so it needs to be negative. Okay, so I'm going to have negative 3.4 times 10 to the 3 joules. Okay, the change in my kinetic energy was negative 1200 joules, negative 1200 over here. Okay, then that's all going to be divided by the mass times gravity. Okay, so the mass of the object was 200. Okay, gravity is 9.8. And then minus my initial height, which was 10 meters, will equal to H final. Okay, so if you now go and plug this into your calculator, you should get a final height after rounding off. So H final should equal 8.88 meters. Okay. Now for question 5.4, okay, it says on reaching point B, the car's engine is switched on in order to move up the incline to point C. Okay, so we've now included the engine, so therefore we have to include the work done by the engine. Okay, it says here that C is 22 meters above the ground. While moving from B to C, the car travels 15 seconds at constant speed of 2 meters per second. Okay, please take note of the constant speed, and then while an average frictional force of 50 newtons acts on it. Okay, so it says calculate the power delivered by the engine to move the car from B to C. Okay, there's quite a lot happening here, but let's break it down. So we're moving from B to C, so let's write down everything we have. Okay, then once again we're dealing with non-conservative forces. Why? Because we have friction and an engine coming into play here now. So we're going to use work of the non-conservative force again. Okay, so let's get started with this one. Also, just note quickly that the work of friction, okay, remember, work is equal to F net delta x, okay, over a given or change in distance. But remember, change in distance can be calculated from velocity. Okay, so remember, delta x equals to velocity times time. Okay, that's why they've given us 15 seconds and they've given us a constant velocity of 2 meters per second. Okay, now because my speed is constant velocity, I have no kinetic energy because there's no change in velocity, so therefore there's no change in kinetic energy. Okay, so once again we're going to have work of the non-conservative equals to change in kinetic energy plus change in potential. But remember, we have no kinetic energy, so what we're going to end up having is work of the engine plus work of friction is just going to equal to my change in potential energy. Okay, so once again, if we rearrange everything to find the work of the engine, we're just going to have work of the engine equals to change in my potential energy minus the work done by friction. Okay, so this again is going to be change in height. So that's mg h final minus h initial. Okay, but now remember, work of the frictional force is going to be the net force, 50 newtons, multiplied by the velocity and the time. So that's going to be F net multiplied by the velocity multiplied by time. Okay, so now if we substitute everything in, we're going to get 200 times 9.8, okay, So V final is 22 minus V initial, which was 8.88. Okay, minus then everything that's given here. So that's 50, 2 meters per second, and 15 seconds. Okay, so if you put that into your calculator, you should get a total work of the engine, which should give you 27,215.20 joules. Okay, but remember, you're not done with the question here because we have to calculate the power. Okay, so remember, power is the amount of work done over a given period of time. So P equals W of the engine over delta T. But now this delta T, remember, it took 15 seconds to get from B to C. So that's your delta T. So I'm going to take 27,215, divide that, 0.20, divide that by 15 seconds, okay, and that's going to give me my power. So you should get a total power of, let's have a look here, 1,814.35 watts. Okay, and that's how we go about doing this question. Okay, if you found today's video helpful, then please leave a thumbs up. If you have any questions regarding this question, then please leave them in the comment section below and I'll get back to them as soon as I can. Please consider subscribing to the channel. It does help a lot. Go check out the channel. There's maths videos and there's chemistry videos as well. And thank you for watching.